books or resources. I don't necessarily have like a huge supply of resources on my bookshelf. I do have a little bit of stuff, and I will mention some websites here and there of just little things that I have found have been helpful. When it comes to, you're going to get a little bit of my philosophy in life. So when it comes to this kind of stuff, yeah, there's a lot of websites, a lot of YouTube videos of disaster preparedness and prepping and bugging out, that sort of thing. Lots of resources out there. There are a couple of books that I think are interesting. This book by Jerry Franklin is really good in that the first part of the book addresses the issues of spirituality and mental, the whole mind, your emotions, and just getting that set right. When times get hard, people who aren't established in a good mental and moral and just emotional place tend to have a much harder time in life. And I don't know about you, but in the last 20, 30 years, you can almost literally see the precipitous drop of mental and emotional stability in our society around us. Things are just getting crazier and crazier. The Franklins tend to come at things more from the standpoint of just in-depth country living, which is good. It's a good book. Another book that I would recommend that really doesn't have anything to do necessarily with this, but it's where our pioneers came from. It's called The Spirits of 76 by Eric Sloan. It really highlights the attitude and just the mentality of our earlier progenitors of our country. And what it's talking about, Spirits of 76, is, just let me turn to the index here. Actually, it doesn't have it. But first chapter is Spirit of Respect. That character of humanity that really holds a society and a neighborhood and neighborly involvement together. I think that is profoundly lacking in our world today. The next one, the spirit of hard work. I mean, what drove a handful of people to get on a boat and travel for months and months to they did not know where? You know what I'm saying? I mean, would you have the guts to do that? Get in a boat that would fit lengthwise in this building and travel across an entire ocean to carve out your existence. I mean, we just don't have that fortitude in our Constitution today. And this really kind of gets at that. The next one is the spirit of frugality. And it contrasts the waste of our society today and just what we throw out in trash. And how, the early pioneers, frugality was a godly virtue of the time. Anyway, it's some philosophy that I really enjoy bringing myself back to as far as meaning and purpose of life.
What's that one called?
The book is The Spirits of 76 by Eric Sloan. It's still out there. You can get it on. interesting books. I don't know where this came from. I think my kids dug it home. Intriguing. No such thing as doomsday. It's out there. You can find it. But this has got like just a million different subjects. A little bit of a caveat or a disclaimer here. They get into some subjects that are a little bit, I don't know, conspiratorial maybe. But there's some good practical information. Very, very wide range of disaster and kind of society meltdown concepts that they mention in there. But it's a lot of good. It's a toolbox. Toolbox in a book. It's got a lot of information in it.
Who was the You Can't Survive? Who was the author?
Jerry J-E-R-E Franklin. Good book.
Thank you.
Yep. Okay. So switch gears. The real title of this section is alternative. I always want to say fire first, but it doesn't sound good to say fire water. Alternative water, fire, and cooking. So when the earthquake or whatever it is that disrupts our daily life, it's nice to know, because disaster almost by definition involves to some degree contaminated water sourcing. I don't know if you remember, what was it, a few years ago, the disaster in Haiti. I think it was a hurricane? Earthquake, yes, it was an earthquake. And we were having, a few years ago, we were having just a whole string of earthquakes all around, like the whole Pacific thing. And it wasn't the earthquake that harmed so many people, it was the contaminated water after the earthquake. So water becomes a very compromised but very essential issue in disaster. So we want to know how to deal with water. It comes back to here. It's one of those essentials of life that we gotta have. And if you start dehydrating yourself to the point that your mind, your mind is the first thing to go. When you start getting hypothermic, you start feeling cold, you go through stages. You get cold, and then after a while you start shivering, your body temperature goes down, you shiver uncontrollably, your body's trying to keep itself warm. At some point, your body exhausts the energy capacity, the ATP, to continue that, so it stops, and it starts changing your vascular system, and it starts dilating to send warm blood from your thoracic area, your core, out to your extremities, and it's like, oh, I start feeling warm. You start feeling warm, and that's a really bad sign. And you just start feeling warm because, like I said, in search and rescue, we start seeing gloves in the snow on the trail, and then it's a hat, and then it's a coat, and we know what's happening. They're warm, and they're going home, and that's not a good thing, because the body can't maintain that vascular dilation because it's taking all that warm blood that warmed up your fingers and toes and taking that cool blood back to your core, and then your core starts cooling off precipitously, and that's just not a good thing at all. And the dynamics of that actually changes a lot if you're dehydrated or fully hydrated. So water is very important. What I was going to say is that hypothermia, the most critical thing that goes is your mind, your capacity. And if you start looking at this, you start getting dehydrated. The mind starts going down. So many of these things that, if you've gone for a long time without food, does it get easier or harder, I think? All of these things, lack of air, your mind, it's the mind. Every one of these things, your mind starts going, then you start making really poor decisions. And actually, there's a little graph along the lines of this idea. In a serious, profound disaster, it's only about 3% of the people in any given population that right up here that will do the exact right thing, just automatically, that keeps them alive. You'll get the bulk of people here that don't know what to do, and that kind of either fight or flight or stall, and just freeze and just don't know what to do. And it's just a big guessing game as to, you know, who gets run over there. And then there's always this tail end of about 3% of people that do the absolute wrong thing and immediately get themselves killed, eliminated in disaster. So I don't know about you, but I want to be up here somewhere. So I want to do the right thing. But that takes education. That takes the skill of doing this stuff, not just have it, but practice it and do it, and to play around with it so it becomes second nature. So, we want to talk about this water thing for a minute. What are some problems that we can get in water?
Bacteria.
Biologicals. Bacteria, Giardia, which is a protozoa, viruses, parasites. So, virus, bacteria, protozoa, that's the Giardia. How many of you have ever actually had Giardia? How was it?
Awful.
Not good.
I've
You
heard
got a flu and runs and everything else all at once.
everybody I've talked to said you feel like you want to die. And then parasite, cryptosporidium, parasites. So the biologicals, these things can be a real problem. And you know, if home and neighborhood have been sucked into the next county by a tornado, which I don't know, that's not an issue here. But whatever it is, if home and base and everything that you knew and loved is like gone, including healthy water, and you start coming down with stuff, you really greatly increase your odds of working your way down this graph into this area, and that's not good. What else in our society? Heavy metals, lead, arsenic, cadmium, mercury, copper even, copper. Mercury with an H. These things are part of our daily life. They're in the ingredients of stuff that we use and we drive, and we're just involved with these heavy metals that are extremely toxic. Thallium is another one. Thallium is bad. But they're contained so that we're not necessarily exposed to them in a harmful way, although they are there. But in a disaster, and things get ripped apart and put in the creek and get in the groundwater, heavy metals can be an issue. The other thing are the organics. What's the example of organics? Gas, diesel, insecticides, pesticides, herbicides, fungicides. Those are bad. Let me write this so it looks real. pesticides, herbicides, and fungicides. Those large organic molecules, those are not good at all. And there's just an enormous amount of industrial compounds used in manufacture or whatever it is to produce goods. Big earthquake, you've got lines breaking, you've got all kinds of liquids and things that are getting into the groundwater, getting into the lake, the river, the stream. How many remember the pictures from, what's the place in Ohio that train wreck?
Oh, yeah.
Yeah, Palestine, East Palestine. Remember seeing the pictures of the water, the rivers and the lakes, and they had that pretty little rainbow on it? A pretty little skeleton of death in the water. It happens on a regular basis, and whatever the disaster can be, you've got these things to contend with. Well, how do we get rid of this stuff? There's different ways to deal with heavy metals or gas and diesel. Your water should not smell like diesel if you plan on drinking it. But the biologicals, you can't see them, smell them, taste them. They're just there, and they'll make you ferociously sick. So how do we deal with this? And oftentimes, okay, I want to do a little bit of a demonstration here. Oftentimes, water, instead of looking like this, starts looking like that. So, how many of you are ready to drink that? Stick here. In the winter, I don't know, in the winter when there's a lot of runoff, does the river ever look like that?
All the time.
So you ready to drink out of that? So bad things could happen in the middle of winter when the whole river looks like that and all the creeks look like that. Or the puddles, wherever water is, and if it's looking like that, well, we've got our backpack filter, and we can filter that and make it look good, but that is going to wreck our filter really fast, and that's going to limit the amount of good water that you can get out of it. So, but it's good to have these. This is it's Katadyn, kind of mid-range backpacking filter. You notice it's got two hoses. The out hose, the clean hose, I keep in a bag. You don't want this hose to get like hugging and kissing all over this hose, because this is the one that goes in the mess. You don't want this one contaminated, so keep them separate in there so they don't contaminate each other. The Life Straw, I have another one, this older brand of Life Straw. You can use this to drink water out of that, but again, it's going to plug up really fast, and so you're going to limit your ability to have sustained water supply. So, you want to, now, we could add just a whole bunch of bleach to this and kill the biologicals and take care of that, but it would take a lot of bleach to clean that. We could use a Brita countertop filter, which is primarily a carbon-based filter, and that would take out a lot of the metals and some of the organics, and we could drink that. But again, it's got to plug up a Brita really quick. The other thing that we could do is boil that. Well, it's still going to look like that, but in boiling, if you boil that for 15, 20 minutes or so, you're going to kill most of the biologicals. You're going to get rid of the volatile organic compounds, the light organics that are going to evaporate off, the alcohols, the gas, to some degree, maybe a little bit of diesel. But some of these industrial herbicides, pesticides is just gonna stay there. Highly attracted to the particles, the mud particles. Example of this, I spent many years working in an environmental testing lab. And even today, you can get down in the bottom of the Yakima River and dig up mud and test that mud, and it still has traces of DDT in it. Now it's bound up in the mud. Our country stopped using DDT when? Back in the 60s, 70s? That's 50 years ago. But it's still out there in our environment. Now it's immobile for the most part, and it's just like staying put. So it's not much stress to the environment. But if there's construction that's stirring up the sediment at the bottom of that river, it's coming out, and it will have an effect. So, the old sign, I don't know, maybe some of you remember in the magazines or whatever, it's the DDT was just it's great for society because it kills the mosquitoes, which, have diseases and stuff. Well, it's not great because it stays forever. Matter of fact, there was one of the guys that worked in the lab that I worked at. He worked in the organics department, and they did a study, and I believe they sampled 168 water samples of rivers, lakes, and streams in eastern and western Oregon and Washington. So lakes, rivers, streams. So all of Oregon and Washington. They took 168 samples. Out of all those samples, guess what might have been the most common contaminant at the highest levels? Any ideas? Mercury was in there, but not so much. You'll never guess it. Caffeine.
What?
Caffeine. Measurable amounts of caffeine. And you got to stop and think. How many metric or even standard tons of caffeine is produced? We've got caffeine. How many caffeinated drinks are down in the grocery store? Okay. From pop to coffee to everything in between. You've got soap and shampoo that's made with caffeine. Just start your day. They put caffeine in a bazillion different things. And our bodies don't metabolize that stuff. So it goes in, your body uses a tiny portion of it, but most of it gets excreted. Well, where does it go? It goes to the municipal water source or into the ground if you've just got a regular septic leach line. The municipal water sources, they don't treat and remove all the potential contaminants that humans generate. So a majority of that stuff just comes in and goes out to the river or wherever it goes out to, evaporating holding ponds. So another one that was really high was hormone mimics. So there's all kinds of medications that humans take that are hormone mimics. Well, again, our body doesn't take those molecules and rip them all apart and reuse them. It does what it does inside the human body, but then it gets excreted and it goes out into the environment. So they're finding weird things like fish in certain areas. Normally when a fish lays a million fish eggs, roughly half of them are male, roughly half of them are female. But under very, very minute amounts of some of these hormone mimics and metabolites, they have found that it will actually shift and feminize a lot of the male baby fish to become females. And we've seen that in a number of things out in nature where the compounds and chemicals and just the chemistry that we use has a tendency, well, the estrogen byproducts in plastics. And we scratch our heads and wonder why society is dealing with the issues that we all know we're dealing with in our society today. And we are doing things that we have no concept of the side effects that they produce. So, how do we deal with this? Well, I don't know about you, but I'm thirsty and I want to drink some water, but I don't want to drink that. So I want to pre-filter that. How I'm going to do this, because I want to extend the life of my filter. So, paper towels, and I want you to play around with this and try this at home. I'm going to use some of this paper towel. Also, a fine cotton rag will work as well. But let's just do this. Let's twist this up without pulling it apart. I want to get it wet. Get this right to the edge. Actually, I don't need that. You notice it's all, the water's all over it. Okay, we're just gonna let that go. The finer, so cloth doesn't work quite as good. The finer the fibers are, the better it works. So paper towel works good, toilet paper works good, toilet paper is even finer. But the finer the paper, the better this works. But we'll just watch that.
How about a cloth diaper?
Not really. Well, the cloth diaper, yes, that's full on cotton. As long as it's 100% cotton, it doesn't have any other funny little things in it. How's that water looking?
It's clean.
It's clean, isn't it? Now, with that water, I could run hundreds and hundreds of gallons of that water down there through my straw, and I wouldn't use up the capacity of my straw. Plus, what am I filtering out here? I'm not filtering out the biologicals, but I am filtering out debris and anything that's actually attached to that debris. So, a lot of these metals are in what we call ionic form. In other words, the metal atoms have a slight charge to them. Most of them will be a positive charge. So they're going to be attracted to some of the negatively charged particles of debris in there. So I am filtering out a little bit of these guys here. And also, there's a number of organics that will adhere more to the sediment and the debris as well. So I am pulling out a little bit of metals and a little bit of organics. That's actually working really fast. I like that. It's like sometimes it doesn't pull out that fast. But you notice the water level is going down. So at some point, it works better the more you have on the outside hanging down, because it's pulling by capillary action, and so the more pull you have, you see it started to slow down a bit. Just because the water level here has gone down like almost 3/4 of an inch. So I'm going to have to eventually kind of move this a little bit so the tail end, which you can't see, it's only stuck in the inside the pot about that much. So it's just getting the edge of the water. But it'll slow down as this water gets closer and closer to the edge of the fabric or the paper. It'll slow down and eventually stop right about there. So I'll have to adjust this. And actually, I should have left this on, because if this was left on, then I would have more leeway to adjust that and pick it up clear down to the bottom. But you get the point, right?
Pretty obvious.
So, I mean, you can't get much muddier than that, right? I mean, that was pretty bad water that I started with. And even if we stir it up, it really doesn't affect things. And as you see, where is the filtering happening? It's actually happening right here at the very edge. Because as you remember, I had to dip it in, so I got this contamination here. You have to dip it in enough to pull it out and let it get started. And get the water level out here just past the inside water level. But, you can use a 5-gallon bucket and a whole lot of water, or 2 or 3 of them, and you can be doing this on a larger scale, in a disaster situation, and, really kind of get this into production to get your water cleaned up. And now we're going to take that and run it through our K-Dine. There's so many different kinds of water filters. There's water filters that are essentially a big bag, and it just gravity filters through the little tube at the bottom. Those are really handy, and they're not that expensive. So just scoop up the water and just hang it and it'll drip out. But again, I don't want to be scooping up that kind of water and running through my bag filter. I'll want to pre-filter it to do that, and then I'll put that in there, and then that way I don't ruin my filter. So just like that, keep going. Now, if this is Western Washington, I would drink that, because I've been drinking out of every mud puddle and creek since I was 10, over on that side of the mountains. And so, me and half of these guys have a pretty symbiotic relationship at this point. I've drank out of just about everything imaginable out there.
So your body has adapted.
So I've adapted. This is Montana water, and you guys could probably handle it, maybe. I'm not going to drink that without running it through it, and I don't necessarily want to. You get the point. Another way to deal with this is, this is my wife's water bottle. It's shiny stainless steel inside, and the cap has a UV light in it, so that when you push the button, it sits in there, and it's got a timer, and it runs for however long it needs to run. And again, in clear water, it will sterilize biologicals. Let me not get ahead of myself here. To write something out. In dealing with these 3 different things, we have 2 ways of approaching this problem. Purification versus filtration. There's 2 different things. You are purifying things when you filter, but you're not necessarily filtering to purify. So what's the difference? Anybody?
Isn't it kind of based on the size of the particles that you're trying to get rid of?
Yeah. Filtrating with the right kind of filter can get rid of biologicals, metals, and organics. The biologicals are filtered out by size. So the K-Dine goes down to like half or a tenth of a micron in size. So that's getting out even some viruses. Less viruses, more bacteria, lots of bacteria. It's taking out like 99 point, and then there's like 3 or 4 nines after the decimal. So this is pretty good taking out the biologicals. I don't think what I have in here now doesn't have a carbon element to the filter, but a carbon-based filter, which actually these life straws do. Part of their filtration removes 99 point, and then there's 6 nines after the decimal of bacteria. Removes 98.9999% of the parasites, the Giardia and Cryptosporidium, 99.999939, microplastics. I thought it said something about organics, but I'm not seeing it. Bacteria and microplastics. If it's got carbon, it'll also pull out a lot of these two guys here. So purifying is cleaning what's there. Filtration is removing what's there. So, is it stopped yet? So it's just barely touching the water on the inside here. So we are filtering here, and we are kind of doing a little bit of purification, but mostly we're filtering at this point. Like I said, there's still biologicals living in that water. If we put that under a microscope, you'd see steps swimming around.
Sure looks better.
Yes, I know. So now we're doing this. Now we want to do this. And that's where we get into some mechanisms as to you can purify with the UV light thing here. Like I said, some filters will purify. We've got a what's called a jerry can here. These are a little bit expensive, but they're really neat. I think these are what, about $250, $300. Pull this out, go scoop up, not that kind of water. Again, I pre-filter, but you can just take this down to the river and scoop up preferably clean water. And this holds, I think, about 4 or 5 gallons. So scoop it up with that in, tighten that, and then you pressurize it. This is a really sturdy container, and it feels like a car bumper. Pressurize it, and the actual filter is on this side. So if I take this apart and show you, there's a carbon wafer right there, so that's taking out things that the carbon gets out. But the filter is actually a gel filter, so this is getting down to pulling out viruses as well, which are called an ultra micro filter. So it's getting down really, really small, and essentially it's kind of a gel compound with these little tiny like straws inside, or almost like little veins in there, that the water seeps into, and the pressure from pressurizing the vessel forces that out. And so then you've just got this little turning knob right here, which opens and closes the little spout. And you can attach to a little hose to this, so you can have this set up on a bench or whatever, and have your little hose, pressurize it, and then that's going to let the water out. Really kind of a handy setup.
So how many gallons will they actually do, does it say?
Again, it depends on the water quality. So that's where pre-filtering your water really comes in handy. Because if you can get the water looking like, wow, that's doing really good. And it's still going through, and the water's hardly even touching the rag now on the inside. So that's what you want to do with your water when it looks bad. If it looks clear and like this, well then this isn't gonna plug up your filter. If it's green with algae, yeah, do that. If it's muddy, you know, pre-filter. But if you've got the water that looks clean, then you can run it through your other devices to really clean it up. And then even at that, I could take that water down there, run it through my filter, and then if I'm still kind of concerned, I can boil that. Another thing, I have in all my packs, and I think I mentioned it in there, in all my packs, I've got a metal cup. And the reason why is this metal cup is part of my water dealing with the water issue thing. Because I can use this to boil water too. So I can pre-filter, I can boil the water, always have, like I said, redundancy. So different ways to make fire, different ways of cleaning up water. And so from the cup that I can boil to wherever the water tablets here. So that's another mechanism to clean up water using water tablets. And also bleach. The recommendation on bleach, and this you'll see, you know, everybody's opinion on, but it depends. Oh, and these are simplified notes. 2 drops per quart. That's dependent on, I would maybe use a little bit more, but 2 to 4 drops in clean water. If your water looks murky, it at least double or triple that. And if you are using bleach to purify your water, put the bleach in, shake it up, and it's got to set for at least half an hour to do that kill job. You can't just add it, shake it up, and drink it. Another thing to think about, so I've got this little bag, small bottle of bleach. Well, often you want a bottle with an eyedropper, but don't keep the eyedropper as part of your bottle, because the bleach is going to destroy the metal, or the rubber bulb, just completely decay it, yeah.
Are there absolute times when you do not want to use the water? Atypically, cowboys out in the middle of the desert, they have a bad water hole. Something like might be pH corrupted acid or alkaline, that you can't fix the water at all, that you just want to avoid completely.
There probably is that somewhere. I wouldn't. The pH is really not much of an issue. So a really high alkaline water. Let's say a high desert example. You've got a bowl in the landscape. Nothing is growing there, and the water is evaporated. Maybe just a tiny bit of water in this big bowl, but it's all white and crusty from the alkali, which is magnesium and calcium and magnesium mostly, and just a tiny bit of sodium. Well, those aren't, a ton of magnesium and calcium isn't going to harm me.
Maybe the runs.
Over a period of time, you can overdo it. But the one thing that I would be really concerned of would be, has there been any mining in the location? If there's been mining, then there very well could be really high amounts of mercury, because in the old days they used mercury to extract gold. And mercury is really bad. And the other one is arsenic. Arsenic is something that people used in the old days a lot for whatever. So get to know the area and have a pretty good idea as to what bad looks like. If I'm finding a puddle of water beside an industrial complex, for me, that's a no. It's just like, whatever's in that water, I don't care, I don't know. I'm gonna go up on the hill somewhere where water is coming from somewhere else for me. So, that's what would worry me the most, is
In other words, what you're saying, preferably moving water is better than stagnant still water.
it is.
Water's coming from again.
But, yeah, it kind of goes back to where's it coming from? So again, if I'm doing the bleach thing, which I've got the bleach thing, I've got the filter thing, I've got the tablets, and I've got the metal cup. You see how I've got multiple ways to deal with any water situation. And again, keep your little squeezy bulb by itself. So, not in the bleach, because you're gonna ruin it. And then once the rubber bulb is decayed, then the bleach is gonna spill out everywhere. Another thing too, bleach has a shelf life. So my guess is this bleach needs to be changed out. When you put bleach in something, you dilute it in the water, bleach, I believe, has a half-life of about 2 hours. So in 2 hours, half the amount of sodium hypochlorite is still in there. Another 2 hours, you've got half of that, so a quarter, 16, about 8 to 16, 30 seconds, blah, blah, blah. So it does go away, but it also goes away in your container too, here. So I probably maybe every 2 or 3 months or 4 months or maybe 6 months change out my bleach drops. So just something to stay on top of.
What was the name of the blue jug? The blue jug.
Jerry?
Jerry can. It's a jerry can. Yes. Really a handy thing, but a little bit expensive. And I try not to do expensive because I'm just poor farm boy. Okay, so that's, you got a pretty good handle on water? I mean, if you can make it do that, then, you know, we're ready to filter.